Okay, last couple of examples here looking at UVs. I think I'm going to do these together because they have quite a lot of overlap and similarity. But we have this node here called bump offset. What does this do? Well, it uses a little bit of math to artificially push pixels backwards or forwards. So if I set my height to 0, you can see our texture square fits nicely. We don't get any errors or any movement. But if I plug in a higher value, it looks like the texture is kind of bulged forwards and kind of ahead of where the plane was. And if I use a negative value, it now looks like it's pushed back. And you can see you get a little bit of curvature, a little bit of distortion, because it's doing it based on the camera position. And so you get this sort of parallaxing effect, which works quite nicely. If I push this back even more. And this is great for creating the illusion of depth in our materials. There's no depth here, it's a completely flat plane, but it looks like the material or the texture has been pushed backwards, which is great for things with things inside them. So complex materials where you've got an underneath surface, so glass, ice, magma, stuff like that, you can create this illusion of depth quite nicely. If we do that with a texture, so we have here a height map texture. This is just a Megascans, and it's using a height map in blue, I believe. Yes, I think that's a height map there. We can use that as a texture input to our bump offset to create the illusion of having a little bit of depth. And if I move over here, this can be a little bit subtle, but if we have a look at this brick here, as I move up and down, the parallax effect at the top of the brick is different from the parallax effect at the bottom of the brick, and so we get this slightly more 3D element to it. And if I put that to 0, that looks quite flat. Bearing in mind we're not using any normal maps or anything here, this is just a diffuse texture or a base color, so a normal map would help sort of push this effect further. But if we plug in a little bit, and it has to be a little bit, we go for quite high values, we get quite bad texture smearing. So the 3D effect is better, but you start being able to see texture pixels that have been smeared quite badly, and you get swimming and that kind of thing. So yeah, you can kind of see, hopefully you can see that 3D effect quite nicely now, but you are definitely getting some distortion and smearing happening of those pixels on top of bricks and things like that, because there isn't enough information to fill in the bit that's been pushed forwards and backwards. But it does work quite nicely to add a little bit. Again, not cheap or not free. We're doing maths before we sample the UVs, so we're doing this for every pixel, but not super expensive either. Talking about super expensive, if we jump over to the next example, we can have a look at what's called parallax occlusion mapping. So this is basically the same technique of doing bump offset, but rather than doing just a single sample of bump offset, it's doing many samples of bump offset. Just bring my light round to the front. So let's disable shadows for a second. There we go. So what's this doing? Well, if I just disable this as well. So this is a node that comes with the engine. It's called parallax. Could spell parallax. Parallax occlusion mapping. If you've used any Megascans, Quixel, Decal POM, or text bombing POM, POM stands for parallax occlusion mapping, and effectively it's just doing multiple layers of bump offsets. It's quite a complex node. I'm not going to go too much into it. Lots of custom HLSL and things in here. But effectively what it's doing, as I say, is multiple layers of parallax occlusion. Now it's got two inputs here, min steps and max steps, and if I think they are set to the defaults at the moment. This is how many layers of bump do you need at different angles, and you can see here, you can kind of make out the different layers at these shallow angles. So this, I believe, is the max steps. Yeah, we can start upping that value to something very high, and we're getting a nice smooth value here, but we're also getting very expensive because we're having to do multiple kind of layers of this. Min steps, well, looking directly at our surface, it's less important. We can get away with fewer steps, and that's what that is. And we can adjust the height ratio for how much this is sticking out. Higher values obviously going to give us more depth, but more errors as well. And what we can do is we can adjust this. Now, I wouldn't advise going anywhere near as high as this. This is 32 as a default. And we get a decent result. There's a little bit of smearing happening in the TAA, which isn't ideal, but rather than doing very, very high steps at low angles, what we can also do is just disable the effect, and that's what this is doing. So I'm using a Fresnel, and I'm multiplying that by my height ratio. And so, for example, if I just preview that for a second, at shallow angles, we're going to have very low height ratio. So effectively, we're just going to flatten that out. So rather than compensating for the errors by having lots of layers, which is expensive, we're going to compensate by turning the effect off. And if I put my height ratio down a little, you can see rather than getting, well, there's still a little bit here at the front of the screen, but effectively we're flattening that out from the shallow angles. So we're getting a little bit of three-dimensional depth to it, which works quite nicely. But then when we would get errors, rather than having the expensive fix of having lots of steps, we're having we're just disabling the effect by flattening it out. Cool, that's parallax occlusion. We're using the parallax UVs on all of our sort of material parts, so base color, normal, and the AO roughness. But there's also an option here for rendering shadows. If we turn this on, we get shadows, and because it's got that fake depth, it's able to calculate fake shadows on that really quite nicely. If we turn that height map off, or the height ratio off, you can see it's quite flat. A little bit of depth here really sells that effect very nicely, and we can get away with a lot fewer steps when we're dealing with shadows. We still get that nice 3D-ness. Oh, some quite bad smearing there, fair enough. We maybe need a few more steps than that, depending on what your sort of viewing angles are like. And what we're doing here is I'm plugging in the sky atmosphere light direction, so that's going to be using the default, or the directional sunlight direction. Covered that in the math examples, and we're just inverting it so that it now has the right direction to do the calculations for the shadows. As I say, looks really nice, but it is expensive. Having parallax occlusion mapping materials with lots of steps and lots of shadows is a surefire way to start tanking your frame rate. Depending on what hardware you're on, it's the kind of thing that maybe is going to be a bit more useful in next gen, but you do still get some smearing, and there's definitely errors with that. Might check that in the world to see. It's always worth double checking your materials actually in the viewport, not just in this example. Yeah, so that TAA smearing is actually much reduced here. So I think there's some optimizations happening in the material example viewport where things look a lot worse, as that looks quite nice, quite realistic, quite convincing for the light. And then as we get to those shallow angles, flattening it out to fix the errors, so we're not getting anywhere near as much height. And if I move the sun, whoops, keep it in light, but you can see that material is responding to the shadow. I don't like this new thing. There we go. Works quite nicely. So multiple layers of bump offset UVs, drawing again and again, and then because of the multiple layers and the height map we're using, we can calculate shadows on the object, and we can get this really quite nice result. So something to experiment with. But yeah, be aware of the performance costs. If I just go into shader complexity, you can see it's quite a bit darker than the environment. It's not too dark, but if you're putting this on every material, suddenly your whole environment is quite a bit darker, quite a bit more expensive. That can be an issue for performance. So, okay, quick recap as we finish the UV section. UVs are just gradients. We can use them as such and build our own textures and shaders out of UV gradients. Very, very useful. If we multiply them, we can get tiling. We can clump edge pixels and create these kind of appearing and disappearing effects. We can animate textures for UVs. Just adding time to UVs creates animation. Panning, rotating, etc. We can scale by a center point. Just have to do a little bit of extra math to sort of centerize that thing first. We can gradient map, so plugging a texture into the UVs of a texture gradient will give us a gradient coloring, which is very flexible and very useful. And then obviously we can do UV distortion, a little bit of noise in UVs, creating this kind of animated watery type effect. And then lastly, the bump offset and parallax occlusion for creating fake depth in our materials with a little bit of bump offset or parallax occlusion. So lots of techniques, very powerful things, understanding what UVs are and how they work, and hopefully something you can use in your own work.